Okay, welcome everybody. So my name is John Wall, and I'm an astronomer here at MTSU. I'm one of the faculty members here. I teach in the 5th Department of Physics and Astronomy and also the PhD program in computational science. And I'm kind of the moderator for the panel. And today we're going to have various experts about the eclipse here. And I'm going to just give a short introduction to names. So this is Bob Nemiroff, and he'll tell you a little bit about himself more, but he's from Michigan Tech. This is Jim Tiemann, and retired Goddard, is that correct?
That's correct.
And Joyce Guzik from Los Alamos National Laboratory. And I think that's Thomas Beach down there. Thomas Beach is from the University of New Mexico, Los Alamos. So, yeah, thank you. So I'm going to just pass the microphone down to people and just say a little bit about where you're from and what you do, and why you are coming to an eclipse. So, wow.
Yeah, I'm still Robert Nemiroff so I'm professor at Michigan Technological University, and so I've been lifelong friends with John Wallen here, and for 20 years or so. And so we don't have a total eclipse up there. There's a partial eclipse. So he was fortunate enough, he got one down here. So I'm down here. I've never seen a total eclipse of the sun before. I've seen a couple of partial eclipses. Back when I was a kid, I had this strange box contraption. You're supposed to put your head in the box or something. Yeah. I forget how that works. But I've never seen a total eclipse, so I'm very excited to be here. And I will be part of the festivities tomorrow answering questions. So I do teach astronomy and physics, but astronomy also at Michigan Tech. Sort of like Winterfell. Think of it as Winterfell. And I'm excited to be here, and if I can answer questions, I'd be happy to.
Excellent.
I'm Jim Tiemann. I'm from Bowie, Maryland, and I work at Goddard Space Flight Center as a retired astrophysicist now. I work there 1 day a week now, just keep things going. One of the things that I try to keep going is a radio astronomy project that we have been doing for 18 years called Radio Jove. And it's an education and outreach project where students build a radio telescope. And we've distributed about 2,300 of these kits over the 18 years that we've been in existence. Chuck over here is a co-founder and distributor of the kits. They're distributed right here, Middle Tennessee State. And so we'll be using these kits to the radio telescopes from a number of observers to see what kind of ionospheric effects are shown by the eclipse. So, on.
So my name is Joyce Guzik, and I work at Los Alamos National Laboratory in Los Alamos, New Mexico. And in graduate school is where I met Dr. John Wallin. And I'm here partially to visit him and his wife, but also to see the solar eclipse, obviously. Right after and even during graduate school, I was studying the solar interior, making computer models of the inside of the sun. And I've branched out since then to making models of the insides of other stars, because we can learn about unsolved problems in the sun by studying other stars. And I've been using data from the NASA Kepler spacecraft to do some of that work. Because of my involvement with the sun and the stars, I was able to go to 2 conferences internationally that they had near an eclipse path. So in 1995, I went to Vietnam and saw my first total eclipse, and it was near the Cambodian border, and it was only about a minute, and there were cirrus clouds, so it was touch and go on whether we could see it. And then in 1999, I went to Hungary for a conference on the sun and stars and was able to see a very nice total solar eclipse. So I'm looking forward to this one. This will be my 3rd one.
My name is Thomas Beach. I teach astronomy at the Los Alamos branch campus of UNM. I came here with Joyce because we're married. And as she mentioned, we both went to graduate school with John. I've seen 2 eclipses. One was in 1979 when I was an undergraduate. That was up in Canada. So we all got loaded in a bus, drove up there, looked at the eclipse, got in the bus, drove back. And the other one I saw was again with Joyce. She mentioned we were in Hungary in 1999 and saw that eclipse. So I've tried to see 2 and they've been clear. So I'm good luck for eclipses. So I've brought my good luck here to Tennessee.
So I'll just say loudly. So let's just talk about a little bit about tomorrow. So what are you looking forward to? What are you most looking forward to about the eclipse tomorrow? I mean, there's lots of things that are going on. In totality, there's diamond rings, there's Baily's beads, there's shadow bands, there's all these different things. So if you could describe what things you're looking forward to seeing and kind of describe what that is, that would be helpful. So I'll give it to Bob.
Darkness. Yeah, I just want to experience it, you know, how it's dark during the day and how you can see stars and how you can see the corona that goes out that you normally can't see because the sun is too bright. And I'm just going to try to take it all in. It'll be about a little more than a minute here, is that right?
Yeah.
And I'm just going to try to take it all in and hope it's clear enough for that. Just the basics for me. I'm just going to be excited to see the basics.
You don't have to applaud after every answer. It wasn't that good of an answer, let's face it, guys. Just the good answers. Sorry.
Okay, set the bar.
I know. Got to put some standards here.
Yeah, I've gone to 3 eclipses and been lucky on 1, so I'm happy there's better luck along. I'm looking forward to what I hope is a clear sky eclipse, because to me the most amazing thing when I saw the one that I did in Turkey that was really pure clear sky, the most amazing thing was like 15 or 20 seconds ahead of totality. It was still pretty bright. It was amazing how bright it is. And then in the last few seconds, it goes from fairly bright to really dark. And so that's the reason it's kind of important to get on the path of totality if you can.
Well, when I was in Hungary, I was really impressed by the corona and the coronal streamers. And I am planning to spend most of the time looking during totality with my eyes and not taking photos. I'm trusting Tom, who's been practicing, to take very efficient photos. But the streamers are so beautiful. They have so much structure in them. And with your eye, you can see it much better because of the dynamic range of your eye than you'll ever see with a single photograph that you take. And I know now in the digital age, we're able to put these together and make composites and try to bring out some of those features. But I still, to this day, think that what I could see with my eye was much better than any photo I was ever able to find of that solar eclipse. So I would encourage you to take a look for all the structure, and they almost look braided and churning. Those coronal streamers, usually you see kind of washed out white rays coming out of the sun, but it'll have a lot more structure, I'm hoping, with your eyes that you will see. And try to remember how that looked, because I don't think you'll find a picture that does it justice later. I may be wrong, but we'll see.
In 1979, we were up in Riverton, Manitoba, and we were in the middle of a huge field, open area on a hill, and you could see off in the distance as the eclipse was coming, you could see the shadow approaching, racing across the landscape, which was extremely cool. In 1999, I didn't get to see that because there were trees and obstruction, so you need a good view of the distance to be able to see that. That was the most interesting thing. I took pictures. Back then it was black and white pictures on film. In 1999, I took pictures, and again, you don't want to take pictures the whole time. So I just take pictures for part of it and then look at the stuff. Because as Joyce says, your eye can see things that the photographs are not going to do justice to. I took pictures on slide film in 1999, and this year I'm going to be using digital camera. So, you know, it's been different each time. One of the things I did not do, the first eclipse I went to, was people talk about how, oh, it gets dark, you can see stars during daylight. It's like, oh, I didn't see any stars because I was looking at the sun, you know. In 1999, I did remember to look at some stars. So during the total eclipse this time, Regulus, which is a fairly bright star, will be just to the left of the sun. Off to the right of the sun, your right, will be Venus, which is very bright, which is not a star. And below it will be Procyon, which is a bright star. And below that, closer to the horizon, will be Sirius. It'll depend on clouds. But, you know, so I would glance at some of that. The other thing is I found during my second eclipse, using a pair of binoculars during totality, you can see a lot more detail. Now we need to be clear on this. You do not use binoculars on the sun when it's not total. Right, so during partial phases, don't be playing with the binoculars. You know, you got the special eclipse viewing glasses that John is going to be passing out at their event here. But when it's total, it's safe to look at. Just make sure that you're not looking at it with anything, even your naked eye, so it's coming back out of totality. But I find the pair of binoculars was very exciting.
John, have you seen a total eclipse? Will
I-
you be emceeing the event tomorrow?
I am. So I saw the same eclipse that Tom did in 1979 up by Winnipeg. So the same thing. I was in high school. We drove up we drove up the day before, and basically that morning we went to the final distance up to Manitoba. The thing that I remember vividly was how cold it was. So it was February 26th in Winnipeg. So the day started at 15 below. And then the sun went out, and it got cold, and it got to about 38 below. I think that we were there. It was really cold. Tomorrow one of the things about the weather forecast that's interesting is they're saying that's going to reach 93, 94 degrees by roughly 3 in the afternoon, right? So, but at about noon tomorrow, it's going to be about 90, 88, 90 degrees. Over the next hour and a half, you're going to see the temperature drop by about 12 degrees. So it's going to reach 90, it's going to get down to somewhere around 80, 78 degrees or something like that, then it's going to go back up again. So it'll be difficult to reach the highs, and it should be cool off as the eclipse is going on. Still will be humid, it's still, you got to take precautions, but it'll get a little bit better. So I guess, why don't we open up to questions from the audience, because I mean, that's kind of why we're here. So yeah, question in the back, yeah.
Question, concern. I'm from Cleveland, happen to be here in Tennessee with the 6th grade. The question concerns the orbital path of the moon. And I know the moon goes from west to east. And this year's eclipse seems to be going across the United States, northwest to southeast. In 2024, it seems to be going southwest towards northeast. Why would it be in different directions? Although it's in April.
Right.
In 2020.
So the question is about eclipse paths and the directions that they're going to be going at different times. So if you look at different eclipses, you see they have slightly different paths. Anybody want to do? I'll do it. I'll give it a shot. Okay, so here's actually some eclipse paths up things. So one thing that's interesting is if you look at the eclipse path for 2017, the one that's kind of on the upper left there, it has almost the same path as the one in 1999. And this is actually because it's a thing called the Saros cycle, which is an 18.01 year cycle in terms of the moon's orbit. So the moon's orbit is tilted with respect to the Earth's orbit, and where it intersects the sun goes through an 18.01 year thing. So you get the kind of repeating paths about every 18 years for a given eclipse. Now, the reason it's that shape is because the Earth is a sphere. So this is, the moon's traveling in a straight line in a plane, but sometimes, like in our current thing, it doesn't look like it's a straight line, but if you projected that through the Earth, it would be. So the Earth is rotating, but it's also kind of along a straight path. So it's really complicated. It's projection of the Earth's orbit across the moon's orbit across the Earth is actually kind of a straight line, but you have to factor the rotation of the Earth and factor the fact that the Earth is actually a sphere. So It's a complicated question, but it's, yeah.
Is the plane of the orbit
Plane of the orbit intersecting the rotating Earth.
around the Earth always the same?
Yeah, but the plane of the orbit does, where it's intersecting and what part of the Earth it's intersecting matters. So if you're intersecting, for example, just the eastern edge of the Earth as viewed from the sun, you're going to get a different projected path than if you do the western thing. So does that make sense? Yeah, next question.
I've heard that people chase eclipses, and if you went fast enough, could you be able to follow a eclipse? I see what every day.
So the person who's seen the most eclipses is Jim. So chasing eclipses, we'll give this to you.
Very good question. The shadow of the moon actually goes across the Earth, in this case, I believe at a speed of approximately, it's thousands, 1,500 to 2,000 miles per hour, somewhere like that. So there's only a few planes that can reach that speed and stay up with it. But there are a number of people who book a flight on a plane just to lengthen the time that they're in totality. But usually the plane can't keep up with the shadow. So it's usually just a lengthening to some extent, but not the case where you can stay completely within the shadow for the entire time. Does that answer your question?
You had another part of that question, though, of how could you see an eclipse every day? So that brings up the question for me of how often do eclipses occur? You know, what if you could travel to some other part of the world and see an eclipse tomorrow? Would that happen? I don't know a good number for that, but they're years apart, I believe, right?
Once per year on average.
On average, once per year. Sometimes you get a year with nothing. But anytime you do have a total eclipse, they only last in one particular spot 6 to 8 minutes. What's the record for the longest
You can get up to
eclipse?
7 point something.
7 point something minutes is the longest eclipse if you're standing in one place. But if you were in that airplane, you could make it last a couple of hours, right? If you could follow it. But then you would have to wait a year, maybe more, and go somewhere else in the world to see another one. He has another question, I think.
Can I just say, you only see eclipses during new moon. So there's only once a month when you would get you would get a chance for the moon to come between the Earth and the sun. Besides that, the moon is generally not between the Earth and the sun. So once a month you get a chance, but since the moon's orbit, usually you'll see the moon go over the sun or under the sun. It has to be just right to go across the sun. And that only happens every 18 months or so. Somewhere on Earth.
So other audience questions? Okay, so let's talk about a couple other things. So, oh, yeah, sorry. Yeah, sorry.
Why is our totality so short here of only a minute and 4 seconds?
So why is it only 1 minute and 4 seconds where it's 2 minutes and 34 seconds at the center? So right behind us is a nice diagram. So the thing is that the moon, and if you notice a little circle around Clarksville, that's what the actual moon's shadow looks like when it's projected on Earth. So can you circle that, Chuck, with a mouse or something? Yeah, there you go. So there's the actual size of the moon's shadow is projected on the Earth. Yeah, so it's only about 70 miles across. So if you notice, this is passing across Earth. And if you notice where we are, we're kind of at the lower side of the edge. So we're going through a part that's just a little bit narrower. So we get 1 minute and 4 seconds versus the full width. And the thing that's astonishing to me is how this drops off, right? So if you go south on Church Street here, and you cross I-24, you're outside totality. That's like 3 miles, right? 3 miles out, and we're at the edge. So it drops off really rapidly. If you're out at Stone River Mall, you're at 30 seconds. So it just going a few miles makes a difference. So, and if you're in Christiana or Eagleville, you're not seeing anything in terms of totality. The difference between totality and not totality is 10,000 times in sky brightness. So, because most of that drop off is in the last 20 or 30 seconds. So you got to be in totality. You should come to our party on campus. As I put in a plug for a party. Yeah, next question.
I teach in Shelbyville, and the kids on Friday were asking me what they're going to do there.
So,
I know it's not totality, but I.
so let them go home. Yeah, excellent. So Shelbyville's outside totality, they're going to be at the 99% level approximately for totality. So what they're going to see is something, so if you look at the fourth diagram down, it's going to even be more extreme than that. It's going to almost be dark. It's going to almost be, the moon's going to almost be, covering the sun, but it won't quite cover the sun. And just a little tiny amount is going to keep the sky very bright. You'll notice it getting 60 to 100 times dimmer, but it's still never going to get dark out. You might be able to see the planet Venus.
Okay, so they'll get a crescent.
They'll get a little tiny crescent, exactly. Exactly. It won't go to full diamond ring, but I'll get it to be a crescent. Yeah.
And you can't look at it directly.
Right, they have that.
Yeah.
Yeah, good.
Awesome.
A cool thing to do in that place is to look at the ground under a tree, because then the light will be going through in between the leaves of the tree, and then you normally see something that's not easily recognizable as images of the sun, but right near, as close as it gets to total eclipse, you'll see lots of little images of, that's it, lots of little images. So I would find a tree where light is going through the leaves, and you might hang out there in Shelbyville, is it?
Shelbyville.
Shelbyville.
Yeah.
Assuming a person's assumptions of where, like, let's assume tomorrow it's clear everywhere, and so you go here, you go there. I live in Murfreesboro, and our house totality, it looks on Google Maps about a minute and a half. His house is going to be like at the full capacity. But he has a much wider open space of viewing because he's got a farm. Is that better, or is it better to be in the city if you have trees? Because like in preparation, I've seen this picture. That's something I can see hopefully in our yard. If you go out to open fields, you're not going to have.
Yeah, both are going to be fun. So whether you go to an open field versus non-open field, so you'll see different things. If you have trees, you get to see this kind of event. If you have a big open field, you might be able to see the shadow coming across.
Okay.
Being on campus, the thing that I think is going to be fun is the crowd.
Right.
The crowd's going to be fun.
My other question is, should you try to optimize the length of time that you're in totality, or should you just take what you can get?
So I think one of the things to think about is the traffic tomorrow, and it's potentially going to be really bad. We don't know. We've never done any clips here before. Since MTSU has been around, so this is a thing. So we don't know what it's going to be like. We have potential for a lot of cars coming in because actually the forecast here is looking pretty good in this region. If you're even coming from Kentucky or from Georgia, you're probably moving to this area tomorrow. So a lot of people are going to be funneling in here. I think we really don't know what the traffic's going to be like. So that's the thing. If you plan on going away from your house, plan on some time to get back. I've urged people to be courteous and to not go anywhere for 2 hours after the eclipse because I have friends that have to get to the airport. but I don't know if that's going to work. So
I'm sorry.
that's okay.
So I've seen some of the YouTube videos of people watching eclipses. I've seen there's one in Mexico. There's got a lot of views. There's one in Patagonia, Australia, a few years ago. And it's hard to tell from the pictures. Like what seems to me we're using tomorrow is very direct. It's right.
Yeah, it's almost overhead. Yeah.
Very overhead. What would be the difference between that versus some of the pictures or videos I've seen where it seems to me it's later in the day and the sun is already starting to set?
So tell me about the Winnipeg one. You can probably use a lower angle up there. Do you
The one
want
I
to?
saw where it was low and you can really see the shadow. It's very awesome.
Well, if you look at that eclipse path, you can see that it stretches across a wide part of the globe, and some of those other eclipse paths where they're just barely crossing the globe, you can end up with, depending on when that crosses you, the sun may be high in the sky or it may be very close to the horizon. So we're lucky here because high in the sky is better for chances of being able to not be obscured by clouds, because lower in or toward the horizon you are, it's a bigger chance of being covered with clouds.
Yeah, go ahead.
I'm visiting from Manassas, in the Colorado area.
Awesome.
So I've read about how the eclipse can have an effect on the animal life, start going into the night phase. Do scientists study if it has any lasting effects, or if, say, there's a particular area of the globe that gets more eclipses than usual, does that affect the animal life in that particular area?
I don't know.
I don't think so, because these happen so rarely that it's probably not something that's been tested. And anything like a sudden thunderstorm coming in, blocking out the sun and making lots of lightning and noise is bound to confuse animals, just like an eclipse will, and they get over that. You'll get over this too.
I was gonna say, my cats haven't gotten over the fact that we moved the cat tree, so, you know, it's hard to really measure this. Yeah, go ahead.
What's gonna happen with, the streetlights in the event area?
So I can take that one. So the streetlights on campus, we're turning them off. So, yeah. Most of the lobby area of the science building, we've turned off. We're gonna have most of the power off here. We're gonna make it as dark as possible. So we have to get campus to do that. We have to have the campus electricians. We've had planning meetings in this room, and we've had like 40 people. We have electricians, we have emergency response, we have t-shirt, it's crazy amount of meetings. And Andrew Ottman's been coordinating this. He's been doing an amazing job. So yeah, we have stage, we have performances. The event tomorrow on campus, we're going out to, the last count I heard was 27 different TV stations. So,
I'm over that now.
yeah, what are you up to, Ty?
Closer to 40. So that's
40 TV stations. So, yeah. So that I didn't know that till Friday, and I'm going to be on the stage. It's freaking me out. So anyway, my goal during the eclipse is to not say, yeah, "Oh my goodness," "Oh my," over and over again. That's my goal, because I'll be live mic'd. Yeah, good.
I was listening to a program on NPR a couple days ago. They were talking about California power system is going 60% solar.
Wow.
And so they expect brownout.
Nice.
Are we expecting a brownout here?
I think we're pretty much nuclear power and coal power here, so we're probably good. I mean, I think everybody's going to be outside, so air conditioning load might be lower too. I actually don't know. So air conditioning load is going to be lower as well, which is interesting, right? So we do, I think our College of Basic and Applied Science has a charger on our golf cart that's solar powered though. Yeah, so I'm just thinking that's not the perfect vehicle for tomorrow, but yeah, it's a good question though. It's actually not obvious how that's going to go.
I do have a friend of mine who's flying through the eclipse.
Oh, wow.
And so, is there like rules? I mean, I can't imagine everyone getting up in their plane and flying. I just wonder how much space there would be.
Well, so yes, I'm a pilot, so I've been looking for official, widespread notices to airmen about that, and I haven't seen anything official, although you said that you see some notices up for the eclipse thing?
No. I'm not sure if, in most cases, people are going on commercial flights, and the commercial airline, I guess it's up to them whether they decide to deviate a little and follow the path. But charter flights, those are liable to be along the same path, and I assume they have to deal with that somehow.
In the drone community, there's been a fair bit of concern about true amateur people as opposed to amateurs trying to fly to get photographs, and the traffic, drone traffic can be a problem. But airplanes are currently keeping an eye on that, and there's enough difference in the flight paths that that will be okay. But if you're keep an eye out for kids with drugs, and kids can be good for your goals.
So I think one of the things I think the traffic on the ground actually might be a bigger issue. Air traffic, people will probably turn on the navigation lights, and totality doesn't last that long, so people will probably take appropriate actions to make it pretty safe. On the ground, the danger is people could be driving somewhere, and I don't know how this could possibly happen, but they could not know totality is coming up, or they could be on the road trying to get somewhere for totality, and they don't know what time it is, and then they're trying to weave through the traffic as everybody's pulling off. So, make sure you're in a safe place. When you get to a place half an hour before the eclipse, stay there. Don't try going somewhere at the last minute, because it just doesn't seem like that's going to work out well. The other stupidest thing I could think of that could happen tomorrow, which I bet will happen, is somebody will get a set of eclipse goggles on, and they're going to think that they have to wear that all day. And they'll try driving with it, right? And just wait. You know it's going to happen. Just wait.
I'm sure there are some signs around here, but I was noting the signs along the Interstate 40 saying it's illegal to park on the side
Yeah.
during the time of the eclipse.
Yeah, go ahead.
First of all, I want to say New Mexico is my home state. So Alamogordo, okay, Las Cruces. That's where I went to school. And my brother from Las Cruces is coming in a week, so I'm very excited. My question is, because you talked about the glasses, can you explain their makeup and why can't you see anything out of them, like if you're not looking at, I put them on and it's dark?
Yeah, so let's talk about glasses for a second. So first of all, MTSU has glasses for the event tomorrow. We have about 9,000 or so, and we're going to be giving them out, I guess, after 11 o'clock tomorrow. Yeah. Yeah, starting at 11 o'clock tomorrow. Again, you don't need them all the time to look at the thing. So just a couple things. So you're not going to be staring at the sun all the time, so you don't need it. You can share it between somebody. You can go back and forth. So if you have one per family, that's going to work out great. What they're doing is it's blocking out, 99.99% of both the visible light and the infrared light. So you can't substitute sunglasses, you can't do anything like that, because when you block out that much light, nothing else is visible. So you have to block out so the sun looks dim in them. And compared to the sun, light bulbs, are a very faint, pale completely next to them. So there's been some things about fake glasses being out there. If you have any questions about those, you can actually just Google fake eclipse glasses. You can get a list of manufacturers that are okay. My one regret of this eclipse is that I didn't buy 2,000 glasses and sell them today. Because when we ordered them for the event, we ordered them for Rutherford County Schools through a donation from Turner Construction. And so they gave us money. We bought somewhere 86,000 glasses. Yeah, somewhere 80,000 glasses. And so with 80,000 glasses, most of them went to the school kids in Rutherford County and Murfreesboro City Schools. And then we have enough for the event tomorrow as well. But I mean, if buying for 25 cents a piece 5 months in advance and selling them for $4, that's a pretty good deal. Good way to turn money around. I'm just saying. Next eclipse. Next eclipse here, I'm going to do that. Yeah, next question.
Where are you going to be during the
I'm going to be outside here. So I will be here. So I guess, so this is Chuck Higgins, he's another astronomer from the department. He and I guess Bob Nimmeroff are going to be on campus. Jim's going to be at Cedars of Lebanon, I think, doing his experiment. And Tom and Joyce, you're going to be up by Nashville-ish, because they have a flight at 5 o'clock. So, the combination of traffic and totality says get further north. So, yeah.
Someone from Vietnam told me that when he was a child, they had an eclipse where he lived, but he didn't have glasses. So they put a pail of water in the sun's path, and they watched the eclipse in the water.
That's probably a bad idea. No. Yeah, that's probably a bad idea, because you'll get a high reflectivity off the water, and it's going to still be too bright. So, check the other pinhole camera. So if you can't get any eclipse goggles, what you can do is a pinhole camera, and they're really easy to do. You take two pieces of paper like this, and you take a pin, and you literally just poke a pin through one of these, and then project the image, like you can see on the screen here, with a little stick man on the bottom right. So the sun's image will go down there, and you can safely view that on the second piece of paper. This actually works really well. So, yeah, 1998, exactly. So this is the best way to see this. And until totality, this is the best way to view it. I actually like pinhole cameras a lot because you get a nice image. You can kind of zoom in and study it. You try to get the pin as sharp as possible. Some people like to put aluminum foil. And just put a pinhole in it. Make it a nice clean hole, and you'll get a nice image coming out of it. So if you can't get goggles, that's going to be there. Come to campus. Again, you don't need to have just your own because you're going to be handing them back and forth. Even with the glasses, you don't have to stare at the sun for an hour and a half. You probably shouldn't. You're going to be passing it back and forth between people. So, you'll get a chance to see it directly.
If a swath of people decide to take out their phones and start taking pictures, will the backlight from that affect our ability to see?
Yes. Let's talk about cell phones. Turn off your flashes. Turn them off now. So imagine going to the new Star Wars film in December, and just at the critical stage when they're coming down to the Death Star, people take photos with flashes. Your friends won't like you. All the goodwill you get on Facebook will go away because you've blinded the people around you. Turn off your cell phones. Turn off your flashes. You're not going to get a good image. You want to video it? Put it to video mode with the cell phone. You'll get something, and you're not going to have that flash. The key thing is to not have that flash. So yeah, we're going to have a very short time period to get dark adapted. So getting the flashes in addition to that, it's going to ruin your vision as well. So that's even worse than that. Because you're not going to see the corona very well because you've just had a flash in your face. So all the cool things during the eclipse are going to go away for yourself and the people around you if you have a flash on.
A favor, could you announce that tomorrow?
Oh, we will. Yeah, we're announcing tomorrow. Yes, we are announcing tomorrow. Yeah, yeah. I'm gonna say it over and over again until Dr. Higgins. So, yeah, yeah.
You mentioned earlier that you guys, some of you will be doing your work.
So I think Jim's the person doing the experiments tomorrow, and actually Dr. Higgins too, Chuck.
Yes, with the Radio Jobe receiver and radio telescope, we're taking data for as long as we possibly can during the eclipse. And we have a number of the observers around the United States doing so also, close to the path of totality and off the path of the totality. Want to try to see what kind of ionospheric effects there might be as a result of the eclipse. And we're going to basically bring the records together and do some computations and hope we can see something that indicates how it's affecting the ionosphere.
So actually I have a map behind you of the different sites. So.
Okay, yeah. So the stars are observing locations, and you'll notice that they cluster. We have widespread locations, but we try to cluster some that are close together so that we can compare sites that should be seeing something that's fairly similar, and whether or not we can calibrate one against the other. So it should be an interesting experiment. I just hope it works and we get a fair amount of good data. Nice thing about a radio telescope, clouds are not a problem. So cloudy or not, we still get something good. But it should be fun. Chuck, you have anything you want to add? Okay.
I have a question. This is maybe a question. You brought up being dark adapted, and we have a very short time because this eclipse is only 2 minutes, or maximum if you go north. Would there be any strategies to keep your eyes dark adapted? Should you try closing your eyes for 15 seconds before totality? What are some of the things you could do?
So I guess Tom has an answer to that because he has a plan.
Well, I have an eye patch I'm going to be wearing over my right eye while I'm taking pictures and things with my left eye, just so I'm going to take that off during totality, see if that helps. If I wasn't taking pictures, I would just close my eyes for a few minutes before it comes. We've got an eclipse timing app on our iPad that's going to be doing the countdown and everything for us, so we don't have to even check our watches. So you could just keep your eyes closed. There are some things you'll want to look for as a totality approaches, though, but it gets, these are all within like a minute of totality. There may be some shadow bands, some wiggly, shadow lines on the ground to look for. But if you want to maximize your dark adaptation during totality, you can keep your eyes closed ahead of time.
But then you might miss some of the interesting things that happen, like the Bailey's beads and the ring.
Well, you don't look at Bailey's beads. That's something you would photograph.
Yeah.
That's something that happens very briefly.
Okay.
Could you define your term?
Bailey's beads. When the moon is passing in front of the sun, as the edge of the moon is rough because there's mountains and valleys and things poking out. So just as it's covering the sun, you can get like a whole bunch of bright spots right on the edge. And then you can get what's called a diamond ring effect if you got just one bright area there before, so you get like a ring and then a bright spot in the center. These are things that happen very quickly. You can capture them in photographs. At that point, I'm just going to be going with my camera and not even trying to look. I'm just going to be holding it, look, because that's something you can see later. I don't know that you can see that.
You can with goggles. If you have eye protection on, you can actually see that starting to wiggle in the background. But yeah, you have to have a pretty good view and you have to have pretty good eyesight to see that.
But when it gets to like 20 seconds, 10 seconds before totality, it's getting dark rapidly. So, you know, you shouldn't be having your eyes closed at that point, no. You should be looking at stuff.
If you try the eye patch, it's very important, this is really critical, that you talk like a pirate during the eclipse. So, yeah, in the back there.
I can just confirm that the local dollar store has a little packet of pirate stuff.
Oh, nice. Nice. So Dollar Store has pirate patches.
Gold medallion and some other things too.
And wear those two tomorrow. It's really important.
And I'm looking at this side of the room, so there's people over here who had their hands up.
Excellent. Yeah.
For the poor students out there tomorrow, what is the food and drink situation?
So the food and drink situation on campus. So, yeah, thanks. So we have, this is actually our map. If you notice, the international sign of the hot dog in the center is going to be at the KUC. So the KUC has selling hot dogs. We have 3,500 hot dogs. It's important to know. So that's going to be the main thing. So and we're going to also have popcorn and drinks in front. The student union will be open with some of the venues over there. But if you think about bringing a picnic lunch.
You might want to pack that lunch.
Yeah.
Bring some water too. I know if they're standing in the sun.
And there's going to be water and beverages available, and there's going to be drinking fountains. Most of the buildings in this area are going to be open. Let's see. There's going to be self-guided tours of Science Building, WPS, DSB, KUC. Theater is going to be open with a video loop if you want to cool off tomorrow. Science Building is going to be open for cooling off. The goggle areas, you can see the little glasses there and actually above. Those are where we're going to distribute goggles starting at 11 o'clock tomorrow. Let's see. The stage is, you can see just north of that. That's where we're going to have live music starting at about 10:30, not actually 11 anymore, about 10:30 tomorrow, along with a stage show with some people talking and some astronomy panel with Chuck and myself and Ron in the back there. Let's see. What else can I tell you? There's going to be some school kids are coming tomorrow from Murfreesboro County or Murfreesboro City Schools, and they're going to be kind of taking over the LRC building. Also, library's going to have to be open as well, so there's going to be a lot of things open for that. The video screens, so can you point to the video screens, Chuck? There's a video screen there that's going to echo the stage and a video screen there. We're going to try to go black about 8 to 10 minutes on the screens. We'll have a countdown timer only in blackness, but we're going to continue talking for a bit after that. But we're going to try and have just a countdown. So yeah, Andrew Ottman.
John, you're leaving out the most important point.
What's that?
That featured on stage will be Professors John and Chuck, and along with Ron Henderson. And on that stage is going to be a fantastic science show where we're showing the animation from NASA, and we're really explaining what's going to be happening in the skies. And then as Ron talks, then Chuck talks. They'll peel off on stage to go to their different scientific stations, and John and I are going to be left on stage talking it through, almost like a play-by-play analysis of a football game here, where we're going to be, okay, it's coming down the field, and so that the screens are going to be illustrating not only what the professors are going to be talking about, but we'll be switching to the MTSU Observatory feed, so we can see the close-up shots. We'll also be switching to NASA feeds across the country, so we can see those things as well.
Thank you. So, Andrew Ottman, he's the person who's been leading the Eclipse event for us, so should give him a hand, actually. And Ron Anderson in the back, too. So.
Can you just talk about, I'm sorry.
No, that's fine. Sorry.
I know we don't have to have a permit tomorrow, and I know you can park in any non-restricted spaces, but my problem is I don't know what non-restricted means, because there's codes for all the parking lots.
Right.
The other side of the campus.
Anything north of us is going to be open. So here's the basic thing. So the lots kind of on this side of the campus are going to be blocked off. So the thing that's normally behind Davis and WPS, that's going to be blocked off tomorrow. You saw that there's even blocked off already, kind of there's a thing there. So I'm trying to think, the Smith Judd lot, is that going to be open, Chuck, or is that actually?
What is this?
John, everything north of KUC.
Everything north of KUC is open. So yeah, anything north of KUC is going to be great.
Everything down at the
Thanks.
What about the shuttle bus?
So the shuttle buses are closed. Thanks. Yeah. We are going to have a shuttle, I think, available from the faraway gravel lot is going to be over.
But that's only if it goes that far. You should be able to park right in the loop, so it shouldn't be more than a 5-minute walk.
Yeah.
If you're on the north side, no tickets.
No tickets tomorrow.
Anything, just park somewhere.
If somebody,
You see the parking garages are open too for everybody.
Dormitory parking is a safe bet.
you absolutely.
Go for it.
So it's important to note, do not give $5 to anybody for parking, unless they're like one of us. Yeah.
There are hands-on activities. What kind of hands-on activities are there?
So there's a couple things going on with hands-on activities. First of all, making some pinhole cameras. There's going to be a scale model of the solar system going up. What else is happening, Chuck? Two things I know of. Yeah, sorry. We have 6 telescopes up and binoculars up across campus. So we have all these little tents here are going to be available with astronomers that have telescopes. You can, in the partial phases, you'll get a really nice view of the partial phases and the sunspots. You can look through both before and afterwards. It's a slow-moving thing. It takes an hour and a half for the first time the moon contacts the sun to totality. So it's going to be, you've got a chance to look through those. During totality, we just can't do the crowds on it. So we're going to shut down the telescopes for that time period. And then afterwards, you'll have a chance to look through it again. But the hands-on things are mostly kind of for kids. We'll have an Ask an Astronomer booth, so if you have any questions, just come up and ask somebody at the telescope or ask the astronomer booth. I guess Bob's going to be helping with the Ask Astronomer and some of the other events too. So, Bob, by the way, is the person. Anybody heard of Astronomy Picture of the Day? Yeah, that's Bob.
Oh.
So.
Thanks, Bob.
Co-founder of Astronomy Picture.
Show today's picture.
Yeah, can you bring up today's picture? Yeah, thanks. There you go.
There's a video.
You want to show the video?
Yeah.
Yeah.
Quick go.
Full front.
Time lapse. That's called the shadow cone that you would see.
So you can see the shadow going through.
It'll happen again, slow motion.
So you can see this tomorrow.
The bright spot is the corona you see around the sun, which is the very dark spot in the center.
So just as totality is going out, you can maybe pick up on this. You can actually see the shadow moving above us. So a lot of things to watch for tomorrow.
Right here tomorrow.
Yeah. And this is, day or night, so yeah.
They haven't done the observatory?
Observatory is going to be live streaming the eclipse to our screen, so we're going to be cutting to the observatory feed very often. Yeah, the observatories, we're not going to have it, like you can't do tours at times because we have a bunch of stuff set up, but we're going to have things on the screens there. We're going to have the big Jumbotron kind of screens outside as well. Yeah?
What time does it start on the west coast? And is there some way to mathematically figure out how fast it's moving and when it would end on the east coast?
So yeah, so it's about 1,600 miles an hour is about the average speed for tomorrow. So I don't exactly know when first contact is for the upper northwestern United States, but I think it's going to probably be, about an hour before. So
I don't know if this is true or not. You could go out off the Oregon coast and as the sun rises, it'll be
exactly. Yeah, so it'll be starting. Yeah, so as you start seeing things, it's going to happen earlier over there. So several hours earlier. Yeah, I'm not sure exactly what time that is, but again, it's about 1,600, 2,000 miles, so it's going to be about an hour before. We start seeing the first bit of the shadow here when they're probably in totality.
I think 12:30 in Oregon.
12:30?
Where they go.
Okay.
12:30.
12:30 our time. That makes sense. About an hour before. Yeah.
I apologize. We missed the discussion, I think, Joyce said. I may have heard this wrong. You gave concerning the history of eclipses recently. Did I get that wrong?
It wasn't her, but
Someone else. Okay, sorry.
it's okay.
Is there any way we can look up that information? I a bulleted presentation, PowerPoint or something like that online?
Yeah, my Star Party talk, I did a history of Eclipse Star Party talk, that's online at the mtsu.edu / is it, or / observatory?
I don't know.
Probably / observatory. We're not sure where things are.
Video not available.
Okay.
So, yeah.
History one's down? Oh. There we go. So February 3rd video is here. There's a little bit of a talk there. Yeah. Please stop. Thank you. Sure. Yeah.
What is the gravitational effect of an eclipse?
So, I don't know. Do you want to do that, Joyce? Gravitational effect of an eclipse.
I'm thinking on the fly because that's a question I've never asked before or thought of. Well, when the sun and moon align, they have stronger tides, so you'll have tidal effects on the Earth just like you would at new moon and full moon. I don't know that they would be particularly stronger than they are normally at new moon and full moon. So that's what I have to say about it.
Do you want to talk about gravitational lensing, maybe? During detection of gravitational lensing during an eclipse, maybe you could.
I don't, one of these guys can do it better, or Tom.
Yeah.
I was talking to him about that
Yeah, you're a gravitational
project.
lensing guy. Okay, you do it.
He did a research project on that, so.
So then there's been eclipses, so there's some science done at total eclipses, and one of the most exciting science sequences was, I think, around 1919, when during a total eclipse of the sun, they were looking to see how much the sun deflected stars that were right behind it, and the light from stars that are right behind it. And so there were competing predictions. One was by Albert Einstein, which would, if Albert Einstein was right with his most recent theory of gravity, the general theory of relativity, you would see the stars displaced a certain amount. And if he was wrong, then you would see the stars displaced a different amount. And so one of the people everyone holding their breath to see what would happen in the 1919 total eclipse was to see how much the stars were deflected. And it turned out that general relativity was a great gravitational theory and did the best. And that helped catapult Einstein to be a superstar. And a couple years later, to make the Nobel Prize more famous, they gave it to Einstein.
So, can you actually talk about the diagram real quick?
Oh, the diagram. All right, so starlight comes from way far away and usually comes in a pretty much of a straight line right to Earth. So, okay. So here though, but here's the stars here, and so here is actually, it's attracted to the sun. Everything is attracted to gravity, and so it's attracted, and so therefore it appears like it's right here. The stronger the gravity, oddly enough, the more it seems to be pushed away from the sun. It seems counterintuitive, but you can see it this way because it's really being attracted to the sun. So how close the sun appears to the sun actually tells you its gravitational attraction, and back then told you which gravitational theory was doing the best. And so that beat Newtonian gravity, which had been the way of computing gravity for hundreds of years.
So, other questions? Yeah, over in the corner.
You realize we have this great prediction of what time this will occur here in Middle Tennessee State. Do you have an idea and a prediction on what time we're going to try to arrive at campus?
Well, okay, so what time do you arrive at campus? Well, you guys are here right now. Nice lot outside, you know. So the show starts at about 10:30 tomorrow. One of the things we've been struggling with for this whole event is what are the crowds going to be like? And we have literally no idea at all. I don't know, what do you think, John?
I'm saying 14,000.
Right, so, yeah, we have a pool in the physics. I'm saying 19,000, he's saying 14. But when do you think people should be arriving to get out?
Really, anytime between 9 a.m. and noon.
We think, the show's going to start about 10:30. You'd probably be fine if you come 10:30, 11, 12. I would not wait till noon probably to get here. We're going to take a lunch, bring a blanket. There's going to be places to go out and get water. going inside the building.
Are we cool bringing our own, like, umbrellas for sun coverage or like?
Yeah, so we don't have any, we have some tents for shade and we have some cooling, again, you can go in the buildings to cool off. Wear sunscreen, you should adjust your sunscreen during the day as the sun gets dimmer though. I'm not sure how to do that, but talk to your chemist, I think. Yeah, there's gonna be some shade, but yeah. And the student workers, which you are, so we have some student workers here also. We're gonna have some tents to set up and get into some shade. So. Chairs. And chairs, yeah. Yeah, chairs are good too, if you want to bring some chairs. Any other questions? So we're right about 4 o'clock. So if you have any other questions, please come down and talk to us in a bit. I want to, first of all, thank all of my friends and colleagues for coming. I'm going to say just 2 things. First of all, this has been a fantastic weekend for me. I have 11 people in my house right now, 9 visitors, and it's like having a reunion across my life from all the different astronomers that I've been friends with, and it's just fantastic. Second of all, the thing I'm looking for tomorrow is the thing I'm really looking forward for tomorrow is listening to people's reaction to the eclipse and watching your reactions. It's going to be amazing. We have 9,000 glasses, we have a show, we have food. Come to campus, it's going to be a blast. Any other comments or things? You want to do it? Yeah, let's do a quick video at the end here, because that's, let's do a video of what an eclipse is like from a crowd perspective, just so you can see this.
With filter.
It's the diamond ring.
This is you tomorrow. That's what you're going to be going through. So we'll see you all tomorrow. Thanks so much for coming.